backward differences. Last class we studied about forward differences. Now it is backward differences. So here the first backward difference of f of x denoted by del f of x is defined as follows. Here that is del f of x equals f of x minus f of x minus 8. In forward this is delta, but in backward you have to call it as del. Here you have to call it as this operator as del. Remember that one. So now here I will take up to nth elements for table to construct the table. So because n table is very difficult to understand, so I'll take example for up to 5 elements. So here backward difference table. Now here x values. So x I taken here x0, x1, x2, x3, x4 and here x5. So y I'll take y0, y1, y2, y3, y4, y5. So here in forward you started from top, but here you have to start with bottom. You have to start with bottom. So here you have to use del operator. This is del. For to construct the backward difference table, you have to use the del here. So here del by 5, del by 5 equals y5 minus y4, y5 minus y4, that's right. Now here for this one del y4 equals, what do you get, y4 minus y3. Now here for these two, what do you get, del y3 equals y3 minus y2. And for these two difference, here del y2 equals y2 minus y1. And here for these two difference, what I get, del y1 equals y1 minus y0. Here in forward table, what do you get here? It is eliminated last terms, but here in backward table first term is eliminated. So remember that one. Now here I am neglecting these values. So these elements. So here what do you get, delta square, sorry, del square. So del square here you have to start with bottom. So what do you get here, del square y suffix 5 equals, what do you get, del y suffix 5 minus del y suffix 4. And here these two difference, what do you get here, del square y suffix 4 equals del y suffix 4 minus del y suffix 3. And here these two difference, what do you get, del square y suffix 3 equals del y3 minus del y2. and what you get here, last difference, del square y suffix 2 equals, what you get, del y2 minus del y1. Look at here, now y1 is eliminated here, so I'm neglecting these values now, these elements I'm neglecting. So del q here, third difference means here you have to start with bottom. So what do you get here, del q y suffix 5 equals, here del square y suffix 5 minus del square y suffix 4 will get. Now here these two difference, what do you get here, del cube y suffix 4 equals, what do you get, del square y suffix 4 minus del square y suffix 3. Now here these two difference, what do you get, del cube y suffix 3 equals del square y suffix 3 minus del square y suffix 2. Now fourth difference, here I am neglecting these elements now. So here what I get, these two difference now, here del to the power of 4. So del to the power of 4 y suffix 5 equals, what I get, this minus this means del q y suffix 5 minus del q y suffix 4. And what I get, this difference, del to the power of 4 y suffix 3 4 equals what do you get, del q y suffix 4 minus del q y suffix 3. Now what do you get, last difference, here del suffix 5. So here I am neglecting these elements. So what do you get here now, del to the power of 5 y suffix 5 equals, what do you get, del to the power of 4 y suffix 5 minus del to the power of 4 y suffix 4 will get. So look at here, what do you get, delta y suffix 1 delta square y suffix 2 get. So this term is eliminated. Now next in here, del square y suffix 2 is eliminated. Next year del to the power of 4 will get, so del y3 is eliminated. Now here what do you get, y5 will get, so y suffix 4 is eliminated. So last entries in the table are, what do you get here, del y suffix 5 del square y suffix 5 del cube y suffix 5 del to the power of 4 y suffix 5 so on are called leading backward differences. Leading backward differences. So here if you write for up to x to the power of n, this is become y to the power of n, then what do you get here, the last entries in the table are, what do you get, del y suffix n del square y suffix n del cube y suffix n delta to the power of 4 y suffix n so on are called leading backward differences. Remember that one. So here I am taking only for x to the power of I. If you take up to x to the power of n, so these are the last entries, leading backward differences. Now I'll take example. example, construct a backward difference table. Construct a backward difference table for the function f of x equals x cube plus x plus 1, where x takes the values 0, 1, 2, 3, 4, 5, okay, up to 5 will take. Okay, I'll write up to 6 here, 6, and hence identify the leading backward differences. Leading backward differences. So, solution. So here, what is the given? Given f of x equals x cube plus x plus 1, and here the given x values, what is 0, 1, 2, 3, 4, 5 and 6 here. So first what you have to do, you have to construct the backward difference table. Afterwards what you have to find it, you have to identify the leading backward differences. So here, what is f of x? They give here f of x equals x cube plus x plus 1. So put x is equal to 0, find out the answer. X is equal to 1, find out the answer, and 2, 3, 4. So continue that one. So put x is equal to 0. F of 0, what happened? 0 cube plus 0 plus 1. So it will get 1. And here f of 1 equals 1 cube plus 1 plus 1, you will get 1 as it is. So 1 cube is 1, 2 and 3 you will get. So put x is equal to 2, you will get 2 cube plus 2, you have to put x is equal to 2 here, and plus 1. So what I get, 2 cube means 8, 8 plus 2, 10, 10 plus 1, 11. So put x equals 3. So we'll get, what you get, 3 cube plus 3 plus 1. So 3 cube means 27, 27 plus 3, 30, 30 plus 1, 31 will get. And put x equals 4. So if you put x equals 4, what do you get? Here 4 cube plus 4 plus 1. So 4 cube means, what do you get? Totally 4 plus 4, you get 60, 69, sorry. Yeah, you'll get 69, and put x equals 5, we get 5 cube plus 5 plus 1 equals, 5 cube means 125, 125 plus 5, 130, 130 plus 1, you'll get 131. Put x equals 6, you'll get 6 cube plus, here x is there, so you have to put x is equal to 6 and 1. So 218 plus 6, 222, 222 plus 1, 223. Now construct the backward difference table. So here x values, and here y values. So here these are all your x values, and here these are all your y values, because y equals f of x. So here now what you get, x here for 0 it is 1, and for 1 it is 3, and for 2 it is 11, and for 3 it is 31, and for 4 it is 69, and for 5 it is 131, and for 6 it is 223. Now here del, so you have to start with bottom. So here 223 minus 131, so how much you get? It is 92 you get. And here what you get? 131 minus 69, so you'll get 62. And here 69 minus 131, so how much you get? 38 will get. And here 31 minus 11, so we'll get 20. So here 11 minus 3, so we'll get 8. And here these two difference, 3 minus 1 will get 2. Now next difference, del square. Here you have to start with bottom. So 92 minus 62, so how much you get? You will get 30. And here what you get? 62 minus 38, you will get 24. And here 38 minus 220, so you'll get 18. And 20 minus 8, you will get 12. And 8 minus 2, so you'll get 6. So what do you get? Next difference, del cube. Here start with bottom, 30 minus 24, so you'll get 6. And here 24 minus 18, so again you'll get 6. And here 18 minus 12, you'll get 6. And here 12 minus 6, so you'll get 6 only. So what I get here? Next difference, del to the power of 4, so 6 minus 6 will get 0, and here 0. 6 minus 6 will get 0. So you construct the forward difference table. Now what you have to here identify? You have to identify the leading backward differences. Leading backward differences means last entries in the table, or what are the last entries in the table? Here 92, and here 30, and what do you get? 6 are the leading backward differences. Sorry. So here next. So here last class we done for forward table, same problem. Look at here, these two problems. So these two problems here, construct the backward difference table. Today I done for the same function, for x values also same. And for here previous one I done for forward difference table, so for the same function, and x value is also same. So look at here table one. So look at the table here. So what happened here? First difference here in backward 2, 8, 20, 38, 62, 92, and in forward 2, 8, 20, 38, 62, 92. And second difference table 6, 12, 18, 24, 30. Here also you get same thing. And third difference also all are 6, and here also all are 6. So here that means forward and backward table are same for every problem. So you have to remember this one. So next I will take problems. Evaluate, first one here, evaluate the following, evaluate the following. So here first one, delta x plus cos x. Here solution given delta x plus cos x. Here delta means what you get, you know that this is forward, so we have to use forward definition. So what is forward definition? Here delta f of x equals f of x plus h minus f of x. So here what is f of x? F of x equals here x plus cos x. Now right, so substitute in this equation star. So what do you get? Delta x plus cos x, instead of f of x, what do you get? X plus h is there, so x is replaced to x is replaced to x plus h here to do. So what do you get here? X plus h, x is replaced to x plus h plus cos of x plus h minus what do you get? F of x, f of x is x plus cos x. Now simplify that one. So x plus h plus cos of x plus h, plus into minus x plus into minus cos x. So plus x and minus x get cancelled. So what do you get? H plus cos x plus h minus cos x you get. So I'll take these two now. So what you get here? We know that formula cos c minus cos d equals minus 2 into sine of c plus d by 2 sine of c minus d by 2. So what is c here? C is, if you compare x plus h, and d is, you have x. Now substitute for the above equation. So what do you get? So here h is constant, so write as it is. So what do you get? Minus 2 times of here sine x plus h plus d is x divided by 2 into sine of x plus h minus x divided by 2. So here what happened? H plus what do you get? Minus 2 into sine of here what do you get? 2x plus h by 2, and here sine of here plus x and minus x get cancelled, so we'll get h by 2. So this is the required solution for delta x plus cos x. Now second one, delta to the power of n into e to the power of 2x plus 3. So solution, here we know that delta f of x equals f of x plus h minus f of x. So here delta e to the power of 2x plus 3 equals, here this can be written as e to the power of 2x into e to the power of 3. So e to the power of 3 is constant, so I will write outside. So delta into e to the power of 2x. So apply the forward difference formula. So definition. So what do you get? E to the power of 3 into, what do you get here? F of x is replaced to x plus h. So what do you get? E to the power of 2 into x plus h minus e to the power of 2x. You get. So here f of x is e to the power of 2x here. So e to the power of 3 into, what do you get? This can be written as e to the power of x into e to the power of 2h you get minus e to the power of 2x. So I will take e to the power of x common. So e to the power of 3 into e to the power of 2x equal into, what do you get? E to the power of 2h minus 1. So this can be written as e to the power of 2h minus 1 into e to the power of 2x plus 3. You can add the powers. So this is for delta into e to the power of 2x plus 3. Now I'll go for delta square. Delta square into e to the power of 2x plus 3. We want delta to the power of n. So I'm going for next one. So what do you get? This is constant. Take it out here. Sorry, this can be written as delta into delta of e to the power of 2x plus 3. So here this can be written as, here this can be written as, you can substitute here. So if you substitute there, so what do you get? Here delta into, what do you get? E to the power of 2h minus 1 into, what do you get? E to the power of 2x plus 3. So this is constant. I will take outside. E to the power of 2h minus 1 into, what do you get? Delta into, what is e to the power of 2x plus 3 will get. Now what is delta e to the power of 2x plus 3? So again substitute the same formula for here. So what do you get? E to the power of 2h minus 1 into delta, now here what do you get? E to the power of 2h minus 1 into e to the power of 2x plus 3. So what do you get? This becomes e to the power of 2h minus 1 whole square into e to the power of 2x plus 3. So this is for delta square e to the power of 2x plus 3. Now go for here delta cube. So delta cube into e to the power of 2x plus 3. So this can be written as here delta into delta square e to the power of 2x plus 3. So what is delta square e to the power of 2x plus 3? You can write this one here. You can substitute this one, delta square e to the power of 2x plus 3. So I will substitute here. So what happened? Here delta cube e to the power of 2x plus 3 equals what I get here? Delta into e to the power of 2h minus 1 whole square into e to the power of 2x plus 3. So this can be written as, here this is constant, right? So this is constant, x term is not there, so this term is constant. So I will take outside minus 1 whole square into delta into e to the power of 2x plus 3. What is delta into e to the power of 2x plus 3? Here delta into e to the power of 2x plus 3 can be written as e to the power of 2h minus 1 into e to the power of 2x plus 3. I will substitute here. So e to the power of 2h minus 1 whole square into what do you get? E to the power of 2h minus 1 into e to the power of 2x plus 3. So this can be written as e to the power of 2h minus 1 whole cube into e to the power of 2x plus 3. So this is your delta cube into e to the power of 2x plus 3. So here look at here. You have delta to the power of 1, so you will get power 1 here. Delta square you will get, here you will get square, and here delta cube you will get, so this becomes power 4. So here this e to the power of 2x plus 3 all are constant here, so you will get same thing. So therefore here so on, what do you get? Delta to the power of n, e to the power of 2x plus 3 equals e to the power of 2h minus 1. Here what is power is n is there, so n into e to the power of 2x plus 3 you will get. So here take it homework. What do you get? Delta to the power of n into a into b to the power of x, a into b to the power of x. And another one is fourth one, delta into tan inverse n minus 1 divided by n into x, where h equals 1. And fifth one, del into, we'll get tan inverse x. So do it for these three products. So we have to use here backward definition. Remember this.